Hello students. The another very important topic is how to calculate the nature of the cluster. If suppose boranes we have given, we can calculate according to the Wade's rule whether the given borane is closo, nido or arachno. If suppose they are giving a metal clusters like metal carbonyls or some of the metal dimetal binuclear carbonyls. So how can we calculate whether the given compound is closo, nido or arachno? If they are giving such kind of questions, you can see here which cluster is having arachno type structure. First, what we have to do, we have to calculate the contribution of electrons from the each metal and ligand from the cluster part. After that, if suppose osmium, this is a osmium is a group, that is a ruthenium, osmium. So iron, ruthenium, osmium, this is iron group. The configuration is D6-4s2. Outermost electrons are 8. So each osmium can contribute 8 electrons and each CO will contribute 2 electrons. So total it will become, so here you can notice in the osmium 3 CO12, osmium is contributing total 8 electrons. So here total 3 osmium will be there. So 8 multiplied with 3, 24 electrons, and each CO ligand will contribute 2 electrons and total 12 COs will be there. So it is contributing 24 electrons. So the total electrons contributed from this cluster part is 48 electrons. If suppose the given cluster obeys the rule, that is 14n plus 2 rule, then that is closo. If it is obeys 14n plus 4, then that is nido. If it is obeys 14n plus 6, then that is arachno. If that is obeys 14n plus 8, then that is hypo. So let's see here osmium 3 CO12. Here n is the number of metals. So here osmium 3, how many metals are there? Total 3 metals plus 2, how many electrons? Total electrons comes as 48. So if you substitute this one, is it obeys 14n plus 2. So it's given the value that is 44, which is lesser than 48, that is 4 is lesser. So it requires 4 more electrons, that means it is obeying which one? 14n plus 6. So that's why the osmium 3 CO12 is coming under the category of arachno cluster, arachno type of cluster. So the question is, which cluster is having arachno type of cluster? You have to calculate everything like this, and whichever is obeys 14n plus 6, that will be coming under arachno. Let's see another question. White phosphorus P4 belongs to the, either it is closo, nido or arachno, hypo. Same concept here. Phosphorus is nitrogen family. So the outermost electrons are, it is so here this is the phosphorus, which is inorganic, it's not a metal cluster. So you can write the phosphorus which is contributing total how many electrons. This is a nitrogen family. So coming to the boron, boron atomic number is 5. So that is a 5 outermost electrons, and this is a 7. The difference is 2. So here phosphorus, you can also write it as BH2. That means P4, you can also write it as B4H8. That means that is a BnHn plus 4. So you can write like this. So that means the phosphorus is coming under which category? Nido category. So that's why the P4 belongs to the nido. Option B will be the right answer. Coming to the next question. According to the polyhedral electron count rule, polyhedral electron count rule is nothing but if the metal cluster is obeys 14n plus 2, then that is closo, 14n plus 4 nido, plus 6 arachno, and plus 8 hypo. So here I have not written. So here let's see rhodium 6 CO 16. So rhodium again which group? This is a cobalt group contributing 9 electrons. Rhodium is contributing 9 electrons, and it is having how many rhodiums? Total 6 rhodium present. So 9 multiply with 6, so it is 54 electrons contributed, and CO 16, that means each CO contributed 2 electrons, so 16, 32 electrons. So total it is contributing cluster 86. So let's see whether it is obeys which one, whether it is 14n plus 2, or let's start from plus 2. N is the number of metal atoms. How many metal atoms were there? Total 6. So 14 multiply with 6 plus 2. Come as 84 plus 2, so 86. So that indicates here this is coming under closo category. Why? Because it is obeys the 14n plus 2. It is a rhodium 6. CO16 obeys the 14n plus 2 valence electron according to the polyhedral electron count rule. Thanks for watching this video.